All right, folks, we are starting on page 3 in the notes, where we have all this lovely space down at the bottom where we had done our graphs previously. I want you to draw a line, because before we talk about factoring, I think it's important that we talk about foiling. That is an acronym as important as Penn does. Does anyone remember what foiling stands for? All right, that's where we're going to start then. So the acronym FOIL, what it is how we multiply binomials together. That prefix bi means two, so a binomial is a two-termed item. So if we want to FOIL, we are going to be multiplying two-term expressions together, such as x minus 4 times x plus 2. How do we know that this is multiplying? Because there's implied multiplication going on between those parentheses. Why are these binomials? Because x and negative 4 make this a binomial, two terms, and x and that 2 make that a two-term expression. So if you're like, why are we talking about binomials though? It's because when I multiply these, we get a quadratic. So how foiling works is it tells us what we are going to multiply together. The F part of FOIL stands for front or first. And what we are going to multiply is the first terms in both parentheses. That's the F part of foiling. What's x times x? X squared. So now we are seeing that we are getting a quadratic term. The O part of foiling stands for outside terms. So outside would be our outermost terms, the ones closest to the outside of the parentheses. So x times 2 is 2x. That's the O part of foiling, the outside terms. The I part of foiling means inside. So the inside terms is kind of the opposite of the outside. So if x and 2 are my outside terms, what are my inside terms? Negative 4 times x. Watch your signs. We got to take that negative with the 4 when we multiply. So negative 4x. And then the L part of foiling stands for last. Last term in this parenthesis times the last term in this parenthesis, which is the L part of foiling. And it gives us negative 8. What foiling essentially is mass distribution. I've got pop, I've got pizza. I'm going to pass out pop to those two people. I'm going to pass out pizza to those two people. So it's kind of just like double distribution. So notice that we're not ever multiplying the terms inside the parentheses together. We're not going to give a slice of pizza, a can of pop. So you're only multiplying to the other parentheses. So foiling gives us a systematic way of distribution. So our final answer, because we can combine those like terms together, if I have 2x minus 4x, how many x's do we have? Not a plus. Negative 2x minus 8. And there we have it. We have a quadratic in standard form. So quadratic standard form. which is the form we've been seeing for this entire chapter with using negative b over 2a and making our graph. This form up here is also a quadratic, but it is in factored form. And factored form, we actually saw in the previous unit when we were talking about polynomials and their multiplicities. So if I asked you for the degree of this polynomial based on the factored form, I'd take the multiplicity of 1 plus the multiplicity of 1, and that would give me a degree 2 polynomial, which is indeed a quadratic. So we've seen factored form before, we've seen standard form before, but what we haven't done is gone from standard form to factored form. So folks, this process of going from standard to factored form is what we call factoring. Whereas going from factored form to standard form, we call foiling. So factoring and foiling. Have we changed the value of the quadratic here? No, we are literally just changing the way that it looks. And if you're like, why would I want it to look like this over this? Remember last unit when we're like, hey, the x-intercepts would be positive 4 and negative 2. That's going to be pretty useful to us as we start solving quadratics. So factored form allows us to easily find the x-intercepts. Whereas standard form, then we have to do negative b over 2a and find the vertex and do our graph and hope we catch the x-intercept somewhere in there. But going between these two forms doesn't change the value of the quadratic. If I type in factored form, and if I type in standard form, what should these graphs look like? They should look exactly the same. Swoosh, there's factored form. There goes the red line. Right on top of that blue line, that is standard form. So I'm not changing the value of anything. I'm just changing the way the quadratic looks because using factored form is going to be easier to get our x-intercept. All right, is the buy-in good at this point? Yeah? Looking like a much better way than graphing to find those? Let's go ahead and let's explicitly write that. Factoring changes the look, not the equation. Equation value. So it's still the same quadratic, but we're just changing the way that it looks because it's going to be easier for solving. And turn the page. So this leads us to factoring quadratic functions. Section 4.2. So we've done graphing, now it's time to factor. There are two types of expressions, two types of quadratics we're going to be looking at. Monic expressions, which is when your a value is equal to 1, and non-monics, where your a value is equal to something other than 1. So, for example, a monic would be x squared plus 9x plus 20. That's my favorite quadratic. A non-monic would be something like 2x squared plus 3x minus 4. So this has an a value of 1. This has an a value of something other than 1. The monics are much easier to factor. Having that 2 in front affects all of the parts of foiling, the front, the outside and the inside, well, I guess not the last part, but having that coefficient in front of x squared makes the factoring process a lot harder. It's still solving a puzzle. We're still basically going to be looking at pairs of numbers, but the non-monics are a little bit trickier to do. So first, standard form for a quadratic function, 8x squared plus bx plus c. Factoring is a way of undoing multiplication, in particular undoing the distributive property and FOILing, which we saw on the previous page. When we try to factor, the very first thing we always check for is a GCF. It doesn't matter if it's a monic or a non-monic, we always check for a GCF first. Why? Because it's going to make our numbers a little bit smaller. So folks, so we don't forget the stuff that we've already done, what's the biggest number I can take out of 8 and 16? 8. That's the GCF. What else can I take out of those two? Not number-wise, variable-wise. We can take an 8 and an x out from both. So my GCF can be just a number, or it could be a number and a variable. And when I take 8x out, I am taking it out by division. So what happens when I take 8x from 8x squared? We're left with x. What happens when I divide an 8x out of negative 16x? A minus 2. That right there is factored form. And if you're like, wait, what? Factors, because it's something times something else. That's as far as I can factor that one. And folks, let's just real quick take a look at B. Let's just do one more. What is the biggest number I can divide out of both of those? 3. Can I take an x out this time? No, because that 9 doesn't have an x to give away. So we can't divide an x out if there isn't one there to begin with. So what happens when I divide 3 from 6x squared? 2x squared. What happens when we divide out of 3 out of 9? 3. Boom. That's factored form. And the nice thing about factoring is you can literally just check yourself by re-multiplying this back out. So to check, 8x times x, 8x squared. 8x times 2, negative 16x. Same with over here, 6x squared. Plus 9. You don't have to show that check work, but it's a good way to be able to check yourself because we all have bad days where we miss negatives or do the wrong number. So folks, we will continue with factoring tomorrow.